Fun. Feed raw numbers into mouth of functions to figure the answer to work with. Functions process input. You use only the output. So basically, what is a function? It's a machine. It takes an input number. Here, for example, we're going to put 3 into the squaring machine, and out comes 3 squared. 3 times 3, 9. Of course, there are many more complicated functions, and sometimes we don't know what's in the guts of the machine. All you can do is press the buttons on the calculator. So a function is a machine, and I'm going to put in a number, and I want to find the functional value of that number, and it's going to give me an answer. Only one answer. Can't have two. It always comes out the same way. I put in 2 into the squaring machine, I get 4. Put in 3, I get 9. Put in 4, I get 16. Put in 5, I get 25. You get the idea. The machine operates the same way every time, no matter what input you put in, and then you get your answer out. I think every book I've ever taught out of, the first function that is taught is exponents, which makes sense. Sometimes you don't even think it is a function. It's introduced as a shorthand way of multiplying. So either way you want to look at it, you're correct. And let's see what exponents are all about. So here is our first example. We look at exponents like times, but it's not exactly. 6 equals 2 times 3, but 2 times 3 does not equal 2 to the third power. See, 2 times 3, those are two sides of a rectangle. But in 2 to the third power here, the 3 is a repeater number. It is telling you how many times to multiply the base by itself. It's not 2 times 3, it is 2 times itself 3 times. Notice the 3 does not even show up as you work it. It shows up kind of invisibly, as it were, in the fact that you've got 2 3 times in a row multiplying itself. And so 2 to the third power is 8. 2 times 3 is 6. They're two different things. Let's look at the next example. 10 equals 5 times 2. That does not equal 5 squared, 5 to the 2 power, because 5 to the 2 power is 5 times 5. Again, notice the 2 does not even show up. It's just the repeater number and tells you how many times to repeatedly multiply the base, 5. 2 is the exponent. It sits on the base, which is 5. The exponent tells you how many times to repeatedly multiply the base by itself, not by the exponent. So 5 squared is 25. 5 times 2 is 10. Okay, now let's look at some notation here. And here it's right over here. Exponent repeats only what it touches on the lower left. So notice in this example, we have -4 squared. It literally, and this is a notation thing, and to be honest, I'm not sure this is the best way, the consistent way with how other things go, but notation is unchangeable, so we just have to deal with it. So literally, only the very thing that the exponent is next to gets repeated. So notice how I expand it here. There's only one negative, and there are two 4s. Only the 4 gets repeated twice. So it's negative 4 squared, which is different than negative 4 squared. Did you hear the difference? It's kind of lame, but I'm trying to bring that out. Here, the 2 is next to the parentheses, which is like a box. We'll get into that in our action. So the box, and therefore everything in it, gets repeated twice. So this is 2 boxes, which means 2 negative 4s, because that's what's in the box, are timesing each other. So notice the difference of the answers. Up here, you get 2 4s. Down here, you get 2 negative 4s. The parentheses make all the difference. And yeah, so literally, very, very literally, and I don't know if there's anything else quite like this. We usually keep the sign with the number and think of it as a unit. We've looked at it as numbers as arrows. Well, there's other ways of looking at numbers, and well, we've stumbled across one of those. So the only way I keep this straight in my head with the notation, whoever invented it, I don't know if they thought of the long distance ramifications, but literally only the thing that is next to the exponent gets repeated. So try to keep the difference of those two examples in mind, and that will save you, sometimes depending on the sign and depending on the exponent, there may be a difference in the answers, and at other times there may not be. And that's what can be confusing. As we get more into exponents and other stuff later, that'll become more apparent. Anyways, right now, literally, only the very thing next to the exponent gets repeated. Only that thing. Let's look a bit more at exponents. I'm only going to introduce them. There's much more as we get into pre-algebra and algebra later on, but I'm trying to keep all of these first lessons in this section at the introductory level. So we need to come down here now, and we're going to look at some of these rules. So first, let's look at x squared times x cubed, x to the third power. So x squared means x times x. X to the third means x times x times x. Well, of course, we now have x to the fifth. It's kind of like Roman numerals. Which would you rather write? All these 5x's or x to the fifth? Sure, you can say, well, that looks kind of geeky and I don't understand it. Want to just write them out? Well, 6 in one, half a dozen in the other. But as you get into higher math, you don't want to keep writing everything out the long way. You're going to have a full paper just to do a basic problem. So we've got this shorthand. And, it works quite well. And it lets us also do some shortcut with the calculations. Because, for example, I notice x squared times x cubed gives me 5x's, gives me x to the 5. Well, then what do you notice about the exponents themselves? It's a positive 2 and a positive 3, which gives us a positive 5. I can just combine. Multiply, divide is a complementary family of operations to adding and subtracting. And so you can just combine the exponents. Let's do just one here, for example. There we go. And so now if I get, and this works with negatives, if I get an x to the fourth, an x to the negative 2, and an x to the 3. You to draw those out, and yeah, and if you haven't seen negative exponents, don't worry, I am going to skip over this. I'm going to keep it at the shortcut. I'm not going to break it down to the basics. But the answer to this is 4 combined with -2 is 2. 2 combined with 3, oh, this one comes out to be x to the 5th. I didn't plan it that way. It just happened to come out that way. But literally, since you are multiplying these bases, you can just combine their exponents. That's simple. I think you'll find that a lot easier, a lot faster, a lot more accurate than writing out all the x's, then doing some kind of canceling or counting or whatever. So it works. Now let's look at division. And again, we're going to find a reverse because, of course, our friend division is involved. So n3 divided by n2. And if some of you teachers, parents maybe haven't done algebra, I'm using these as placeholders. You can put numbers in here. This could be 4 to the 3rd, and this could be 4 squared. Just make sure that the numbers are the same. The letters here are the same. That means the number inside, that hidden number inside that variable, has to be the same. Don't know what it is? Doesn't matter. It can be any number. N can be a -2. N can be a positive 13. N can be a positive 7. But in this problem, N will always be the same. If this N here is a -7, this N, this N, this one, that one, that one, that one, they will all be a -7. If this N here is a positive 1, these will all be positive 1s. If this N is a 29, all of these N's will be 29s. Okay, so N is any number, X is any number. Okay, so if we look at n to the 3rd, we expand it out n times n times n. N squared gets expanded out n times n. Okay, basic definition of exponents. That's what they're for. And now, because we know that this n and this n are the same number, even though we don't know what it is, doesn't matter. Whatever's going to be in there will be a number over itself, which will be a 1. So that slash is like a 1. We have a 1 times a 1 times an n. Well, 1 times 1 times n, obviously, is n. And now I'm bringing this out because why don't we just do a shortcut? Instead of having to write this all out, cancel it, accidentally count, forget to write enough n's, all that kind of stuff. We can shortcut with our exponents, since that's what they're for, and get our answer. So up here, we combined, and multiplying and dividing are the same family. So down here, we will combine, but we are dividing. So that's introducing a reverse. So notice how we have n3, n3, but then divided by n positive 2 now becomes times n negative 2. We reverse the division to get times, so we make another reverse, counterchange your change to a negative. And now, of course, n to the 3 times n to the negative 2 is simply n to the 3 minus 2, which is 1. And n to the 1, any number to the 1 power, is itself. More specialties on exponents. We'll get there later. But I think you see the idea. I'm trying to show that this pattern with division, reversing a reverse, change a counterchange, still holds. This underlying pattern follows us all the way through pre-algebra and algebra. We've looked at exponents, so now this is our third basic operation. We've had colt, then we had mud, now we have fun. And these all work together to become order of operations. There's still one more, but let's just start introducing order of operations with the three operations that we already have. And so as you look on the action chart, you see 1, 2, 3, 4. In, fun, mud, colt. Always works in that order. You may have heard of PEDMAS. I'll go through that later. But this is still following that same basic idea in case you've heard of it. So this is the same style, order of operations. You can't break it. That's the way math operates. I'm just putting different names on the same style of order of operations. So our first thing is functions. I look at my problem up here, and I look for any functions, and I see one. I see that 2 to the third power. So I figure that I just bring everything else down, and on this line, the only thing I've done is functions. So 2 to the 3 becomes 8. I bring everything else down. Now I'm on this step, and mud comes before colt. So I have to do this times right here before I do my combining. So 5 plus 24. Now my last step will always be combine whatever numbers I have left. 5 plus 24 is 29. So in, fun, mud, colt. Now our next problem. First line, do we see any functions? Yes, we do. 3 squared. That comes down to 9. Everything else is brought down. And in case some of you are looking at it, I skipped the in because nothing's going on inside. I saw the parentheses. It's just being used as multiplying. Okay, now, do I see any multiplying or dividing before I do any adding or subtracting? Yes, I do. Minus 6 times 2 is a negative 12. That comes down, and then the plus 9 is copied. Now, my last step, always my last step, I will combine the numbers I have left. Negative 12 plus 9 is negative 3.